All right, welcome everybody. It's 2 past. Some people are still joining, but I think we can just get going here. I'm Sönke from Stackable. I'll be your charming host today, and I'm talking about mastering data platform security. So basically, I'll be giving a demo of what we, the team at Stackable, have implemented across our stack using OPA to allow you to do proper ACL on your data. All right, so let's get started. First, a few words about me. I'm, as I said, Sönke Liebau, co-founder at Stackable, together with Lars Franke, who's in the call as well. He'll probably be joining the discussion later on. I've been working with big data tools for, I don't know, a good while, probably going on 10 years now, or even 11 years. And in 2020, together with Lars, I co-founded Stackable with the idea of building a modern and open data platform that follows open source principles and mostly, or actually exclusively uses open source software. We are there's a couple of companies that participate in this venture. It's OpenCore, which used to be my and Lars' old company. Betelligent, which is a data-focused consultancy from Germany, as well as Ionos, who use our stack to provide open source tools as a service on their platform. We have a couple of basically core principles that we try to follow when building our platform. Everything should be open source. I don't think we have more than 1 or 2 private repositories on GitHub. Everything should be infrastructure as code, so you should be able to do the same, to apply the same configuration across all your platforms. And actually, a good example that my colleague Sebastian gave me to tell you is that his old company, like none of the dev clusters had Kerberos enabled, but the prod clusters did. So whenever you then moved something from dev to prod, it was always a bit of luck whether it would work or not. And using our infrastructure as code principle, obviously dev and prod and test and all the other platforms should behave pretty much the same across the board. We are cloud native. Everything runs on Kubernetes. So basically, wherever you find a vanilla Kubernetes, our platform should run, which means it runs on premises, in the cloud, in hybrid modes as well. Again, wherever Kubernetes works, Stackable should work as well. We are roughly, get a bit off the way here, roughly 20 people by now. It's a bit distributed throughout Europe because we were founded in the pandemic. So we basically didn't have an office or weren't allowed to have an office initially. So we hired wherever, which was actually quite nice. And yeah, we earn our money doing product support, big data consulting, and giving training for our stuff. Basically all around the things that I'm going to talk to you about. Our platform consists of a lot of open source tools, and a lot of you should probably know a few or all of the logos on here. And I'm not going to talk about all of them, don't worry. I'm just going to briefly touch on sort of the rough categories of tools that we have here. We have like data processing stuff, which is Trino, Hive, NiFi, and Spark to ingest stuff. And then data storage, data integration, with a little bit of infrastructure and orchestration below, and visualization things up top left. And to the right, we have sort of cross-cutting tools, which will be the focus of today, to provide security across the platform, as well as monitoring and logging. And the sort of our main focus on why we call ourselves a platform is that we want things to feel integrated. So security should be applied at a single place across the entire platform. You shouldn't have to go to 10 different tools to configure security for your platform, which is why we chose the Open Policy Agent, which I'll say a few words on the next slide. So first of all, let's have a quick look at the data stack that we'll be using today. We've come up with an imaginary bank, and this bank has 3 departments: marketing, customer service, and compliance, and all of them are using a shared data platform for all their needs, where data processing and data, basically anything data is concerned, they're using the same platform. So obviously we need that to be multi-tenant enabled. And in the stack, we have a couple of tools. I'll briefly touch upon all of them. There's no need to really read the slides to the left. Those are mostly there for your benefit if you download the slides after the fact and want to read up on what I was chatting about. So first of all, we have Keycloak in here, which we use as the centralized identity provider in the stack. Keycloak has the huge benefit that it is able to integrate with a lot of things out the back. So basically, you can integrate it with your ID or your LDAP or whatever you have already existing in your organization. Keycloak will be able to federate across that, and it's a single point of contact for us to retrieve group membership, do group lookups, but also do single sign-on against. So for that, we use OpenID Connect. Which means that whenever you connect to one of the tools in this stack, so most notably in this case, Superset and Trino, you'll be redirected to the Keycloak login page and need to log in once, but not whenever you want to use another tool again. So basically, you only need to log in once in the morning when you come into the office, and then that login will work for you across all the tools in the stack, which is especially useful when you consider things like two-factor authentication and stuff like that, where it's fairly annoying to go digging for your YubiKey or retrieve a code from your phone every time you want to log in. Open Policy Agent, I just mentioned, it's the centralized place to rule the entire stack. So basically one ring to rule them all. Open Policy Agent is a really, really flexible tool that allows you to more or less programmatically express rules that should govern authorization across the entire stack. And we'll actually look at a few examples of later on, so I'm not going to go too deep here for now. But we've integrated all of the tools that you can see on the slide here, or most of the tools that you see on the slide with the Open Policy Agent. So for some of them, it already worked, like Kafka, which isn't even on here. And for some of them, like for Trino, for example, we started writing an authorizer for the Open Policy Agent. And that worked really nicely because the folks from Bloomberg then found that, picked it up, and did many, many enhancements to it. And it's now being contributed back to Trino and being maintained upstream. So that was really nice, open source story there. Then we have a look at Trino, which is the query engine in our stack. Trino is it grew out of Hive in the past, and it's a really, really flexible query engine that allows you to hook up different backends and then run federated queries across those backends. So you can imagine like joining your relational databases with data from your data lake, and maybe even joining in something from your Elasticsearch or OpenSearch search engine, and that providing a single output across all of those backends, and that enables really, really powerful workflows. Kerberos is sort of like an honorable mention here. It's a bit of a blast from the past. It used to be the only authentication tool possible across the big data stack. These days, there's different alternatives. We just spoke about OpenID Connect, for example. But for some of the tools in our stack, notably Hadoop and Hive in this case, Kerberos is still one of the only options out there for authenticating users. And it is still a very good one. It's also a very complicated one that took us a very, very long time to get working in Kubernetes, to be quite honest. But as far as we are aware, it might even be a world first to get this working in Kubernetes and even accessible from outside of the Kubernetes cluster. We did a lot of digging, but we didn't find too many people doing this. Then we've got Hadoop and Iceberg, which is the chosen storage engine for this demo. Quite often these days, we actually see S3 backends being used instead of Hadoop for data storage. It depends a bit on the environment you're in. Usually, like for greenfield use cases where there's nothing provided around, Hadoop is still a very good choice. But especially in larger enterprise environments, for example, there's often a centralized department that provides storage, or if you run in a cloud environment, S3 is always available. So this depends a bit on what's available to you, I would say. But for this demo, since we wanted it to run anywhere, and we wanted to incorporate Kerberos into the mix for demonstration purposes, we picked Hadoop to store the data in, but that's easily replaceable. Hive, I just mentioned, Trino grew out of Hive. And Hive traditionally was two things: a metastore, which stores where tables are in your data engine, and also an actual query engine. So for our stack, we only use the metastore part, because as I just said, the query engine Trino is a more modern alternative to Hive. So we settled on that for the actual engine. But the benefit of this is that if you already have a pre-existing Hive metastore from an existing big data installation, for example, you can simply spin up Trino, point at that metastore, and it'll immediately be able to query your tables from that. If that's something that's interesting to you, we actually have a series of 3 blog posts on our website that I can highly recommend you have a look at. And then we also got Spark, which is kind of your generic workhorse data processing engine, which does the heavy lifting in any type of big data workload. So we have a few jobs running in the cluster. I think mainly extract data from a table and write it to a different table. But in actual production deployments, that'll be like most of your business use cases will probably be expressed as Spark jobs or Flink jobs or any other processing engine that you choose. Oops, went too quick. Superset is sort of the window into the stack. So this is a visualization tool that allows you to create dashboards, reports, query data, play with data. It's very, very good to just sort of explore the data that you have available to you. And it then goes into Trino and requests data from Trino to basically show to you. And time permitting, we'll actually have a quick look at that later on as well. Now, if you look at the picture, you'll notice that there's a couple of different arrows in there, and we've provided a legend to that below. Most importantly for this, what I would like to point out is the pink arrows. Some of them are dotted and some of them are solid. So the solid ones use impersonation, which means that when a customer or a user connects to Superset and runs a query in Trino, Superset will actually instruct Trino to run the query as that user. And this is done in order to exclude any type of sort of privilege escalation where you can use Superset to create a dashboard to view something that you're not actually allowed to see because maybe Superset runs the query as a technical user or something. But by using impersonation here, you'll only ever be able to see data in Superset that you are granted permissions on in Trino as well. And then the arrow from Trino to Hadoop, that's a dotted one, so we don't use impersonation here. It would be possible as well. So basically, when you connect to Superset, Superset tells Trino to run the query as you, and Trino could tell Hadoop to execute this access as you as well. But that obviously means that you need to maintain 2 sets of ACLs to give access to the table in Trino as well as to the files in Hadoop. And for simplicity purposes in this demo, we forwent that. But I have some examples later on. I'll show you the actual ACLs that I applied here to make this a little more clearer. All right, so let's get started with the actual demo. Before I actually demo stuff, I'll briefly walk you through what we've planned for today to make it a bit easier to follow later on when we actually look at stuff, at queries and things in the actual demo. So as I mentioned, we have 3 departments in our bank. We have marketing, we have customer service, and we have compliance. And you can see the main personas for our demo today outlined in pink here. We have Justin Martin and Sophia Clark. Should have made this a bit bigger here. And all of the departments have schemas that they use. So we have one, this is a bit confusing here, I'm sorry, the employee schema below the marketing department, but that's actually, this is a company-wide schema where there's information about all the employees in there. Then we have the customer service department, which has their customer analytics group, and they have their own customer analytics schema, which has your basic customer data, ID, first name, last name, birth year, birth month, stuff like that. And then the compliance team, they've been asked to prepare a couple of reports that aggregate sort of statistics about the users and things like that. So they get redacted view onto the customer analytics schema as well, but they also have their own customer analytics schema with their data. First of all, what we're going to do is we're going to look at general data access and visibility, which is the sort of like the simplest form of providing ACLs on this. So basically, Justin Martin is part of the customer service department. So he's able to see the customer analytics schema. He's not able to see the marketing schema. He's also not able to access the compliance analytics schema. Basically, this is a very simple form of just saying anybody who's in that team gets access to the schema that is assigned to that team. And then expressed in Rego, this would look like, anyway, we'll look at this later on. This is just a little bit of a teaser here now. We will look at Rego rules in depth a bit further on in the demo. Now, to go towards a little bit of a more involved use case, we can talk about column level security and data masking. So Sophia Clark is in the compliance analytics team. And as I mentioned earlier, the compliance analytics team has been asked to prepare a couple of reports about customers. But they should not be able to see all customer data for this because that's not needed for the report. The report should just contain aggregate stuff. So what the compliance department has gotten is they've gotten redacted access to the customer analytics schema. So basically, they are not allowed to see the first and the last name, birth month, and birthday of customers. So everything that's red here, the compliance analytics department is not allowed to see. The blue stuff will be hashed, which allows them to sort of, correlate for themselves, but not retrieve the actual customer ID that they could use in different systems to look at this. And in yellow, the email addresses, those are masked. So as you can see down there, the ABC that'll remain. The first 3 letters of the name part of the email address will remain. The rest is going to be anonymized. And then the domain will be clear text again, so allow, aggregating across email providers of customers or something like that. All of this is obviously a bit of a construed use case to give us something to demo to you, but I'm sure all of you can come up with useful use cases for your specific domain. And then in order to make querying a bit easier, and we'll look at that a bit better in the demo as well, the customer analytics schema contains a view that looks at the customers table, and that only has the information in it that they are allowed to see. But again, the view doesn't store any data. It actually goes to the customer analytics customers table and retrieves data from there and then just shows it. And the second to last use case that we'll look at is row level security. So up until now, we said basically which columns and which tables do you get access to, but we can even look into the tables and restrict the records that people can see when they query data. So for that, we've said the employees table contains information about all employees of the bank, and everybody is allowed to select information about themselves. So mentioned in blue here, if I go into that table, I can select myself, and supervisors can additionally see data about people that report to them. So Sophia Clark, for example, is the team lead in the compliance analytics team. So when we look into the employee table as her in a second, we should be able to see everybody from her team and data about them, which is basically filtering down on the amount of data in the table based on group membership. And then to sort of demonstrate lateral movement in groups, or basically how these ACLs are attached to groups, we will lend Sophia Clark to the customer analytics department by assigning her that group, and then show how that immediately pulls through into the ACL layer and allows her to select additional data. All right, so that moves us right along into the demo time. I have prepared a demo cluster for us today, and I did that using Stackable control, and I installed the end-to-end security demo. I'll have a slide at the very end that gives you a link where you can find that. But if you have Stackable control installed, you can do Stackable control demo list, and that'll give you a list of all the demos that we have prepared. And the demo is pretty much a pre-packaged use case with data and processing jobs and ACLs and everything you need to immediately take a look at something. And what we'll be looking at today is the end-to-end security demo. So I spun that up in preparation for this a little while ago. And as you can see here, if we use K9S, this is now running on a cluster on my machine here. Basically, I've just spun up a one-node kind cluster on my computer and deployed the demo into it. And you can see in here, we've got HDFS running, we've got the Hive Metastore running, Keycloak, Kerberos, KDC. So basically all of the components that I showed earlier on the architecture slide, we've got running here in the cluster and can now interact with those dynamically. And in order to know where to go, Stackable Control has another command, which is called stacklet list. And if you run that, Stackable Control connects to the cluster, finds all the stackable components that are deployed in there by labels that we attach to them, and extracts the endpoints that we can use to talk to these tools. So first of all, what we are interested in for today, I mean, all of the tools are interesting, obviously, but the main piece for today will be Trino, because most of the ACLs actually are going to be applied in Trino today. And what I'll first off be doing is I'll be using a SQL tool, dbeaver in my case, but you can use any SQL tool that you would like, to connect to Trino and run a few queries just to see what data we get access to and what data we can't access. So for that, we need to extract the Trino coordinator URL here. And then we head over to our dbeaver and we'll create a new connection to connect to Trino. I've specifically not done this up front because I wanted to show you that it's actually quite easy to do and how this works. So we want a Trino connection, stick the URL in here, deport back there. And I'll leave the username and password blank because, as I said earlier, we'll be using OpenID Connect and connect to Keycloak for this. So we'll need to configure a few driver properties for this to work properly. First of all, we'll want to use SSL. And then the important one is external authentication down here. So we will set that to true. And what that does is it tells Trino, whenever you connect to this, please go somewhere else for authentication. And we'll see how that works in just a second. And last but not least, we are using a self-signed certificate here. So I'll need to disable SSL verification. Obviously, in a production environment, you should never ever do this. But for us here now, this should work. And now if we click on connect, you can see we are redirected in the background to our Keycloak. And I can now sign in to Keycloak with user credentials for, let's start with Justin Martin here. So authentication succeeded, browser window can be closed, we'll leave it open. And now you can see if we click here, we've got access to Trino and we can see our schemas and our tables. So let's first of all do the very simple thing. We can check out the employees table, and if we click on view data here, this is a bit annoying, but can't be helped, I'm sorry. So basically Justin can select stuff from the employees table and see himself. That's, as we mentioned earlier, that just works. But more important, more interesting actually is of course the customer table. Let's take a look at view data in here. So you can see lots and lots of customers in here, customer IDs. So this is the clear text customer ID, even if it doesn't look like it. A, B, C, D, E, so this is the clear text ID. And then back here somewhere we'll see first name, last name, preferred customer, and you can see day, month, and year of when this customer was born. And at the very back, as you can see, the clear text email address. So Justin has full access to all the customer data in this schema, which is as it should be, because we said earlier he works in the customer department, so he should be able to see all of this. So if we now want to log in as Sophia Clark instead, we'll close this browser window over here to lose our session, and we can disconnect here. And now if I try to connect again, since I closed the browser window, I lost my OpenID Connect session. Now I can re-log in as someone else. And I'll pick Sophia Clark for now. Sign in. Again, successful. And if we now check the tables and schemas that we can see here, as we can see, there's another one that's appeared. So the compliance analytics schema, because Sophia Clark is part of the compliance department, we allow her to see this. She can also see the employees table and the customer analytics table, but those are restricted again. So we'll check out customer analytics in just a bit. but let's have a quick look at the employees table first. And if we do view data here, you can see, sorry for the back and forth there. So Sophia Clark, since she is a supervisor, she can not only see herself, but she can also see data about Daniel King and William Lewis, who are reporting to Sophia. So Trino in the background applied extra row level filtering to ensure that she can see additional data when querying this table. But the ACL that did this is actually the very same. We'll look at that in a bit. And then if you have a look at the compliance analytics team, I'll click on tables first, and that shows up empty because I mentioned this earlier, but I didn't specifically say it. Someone mute themselves, please. I'm not sure who it was. But we have a view in here, which is the customer enriched view, which doesn't contain any data. It just goes through to the actual employees table and queries data from there. And if she runs a select star on this one, you can see the customer ID for her looks very different than what we just saw when querying the same table as Justin, because this is hashed for her. We can also see that there's no first or last name in here. We've got a gender and marital status and stuff like that, but the first and last name have been removed. And also there's only the birth year in here, which is because she only gets restricted access to the employee table. And the email address, as we can see in here, like anything beyond the first 3 letters of the name part of the address has been anonymized. But it doesn't look like it. But since this is generic test data, that this is actually the clear text domain that we have in there. That's been left in place as well for statistical purposes or whatever you want to do with that. But again, this is the view in the compliance analytics schema. We can also have a look at the customer analytics schema just to prove that she actually did get access to the tables in here. What doesn't work now is view data on the customer table, because I'll show that in a second. Basically, what dbeaver now does is it extends, or Trino does, it expands this to give me all columns that are in this table. And since we don't have access to a few of those, this errors out when we try to do it. But what we can do is if we open up a SQL editor, so that was the equivalent of basically select star from Lakehouse Customer Analytics Customers. Yeah, so you can see that doesn't work. But what we can do is if we say we want the email address. So if we do select from, just take this, put it in here, and then customer email address. So that works, because now we only asked for one column that we have access to, but from the table in the customer analytics schema. So Sophia, based on her group membership of that different group, does have access to the table and can actually see data in there, but again, only in a redacted form. There is a workaround that we can do to make the first thing work as well. We can instruct Trino to only give us access to accessible columns. And if we set this session property, now we can actually run a select star on that table as well. And this will not show anything that we don't have access to. So you'll see there's no first name in here. There's no last name in here. There's only the redacted stuff. But she can now run a select star. I still can't click on customers and say view data because this session property doesn't pull through to dbeaver, but that would be possible as well. You have to trust me on that one. So as we can see, this is all here redacted here, but for the last demo use case that I mentioned earlier, what we would like to do is we would like Sophia to temporarily join the customer analytics team. And to do that, we will head over into Keycloak. And in Keycloak, we've got two, oops, that should have worked. Lost my session here. We've got 2 realms configured. Master is sort of for administrative users of our bank, but the actual organizational stuff is all in the demo realm. And if we check here, we can see here's all the users that we just saw. And then in the groups, we can see we've got compliance and regulation, customer service and marketing, basically the 3 departments that I talked about earlier. So in order to have Sophia join the customer service analytics team, we'll head to this group, and we can see current members of this group are those 3. Justin Martin being the one that we used for the demo early on and had him look at the data. So now to make this work, we'll just select Sophia Clark here and have her join this group. And that's basically all we need to do. In the background now, I think there's a 5 or 10 second cache. So hopefully, once we head back here and run this query again, yeah, as you can see, same query, same connection, nothing changed. But when this query now was passed to the Open Policy Agent used something called the group information fetcher and connected to Keycloak and asked which groups is this user a member of. That came back, and now we can apply the different ACLs to this user because of only the group membership that was used for this. So now when Sophia queries the employees table with a select star, you can see the custom ID is now clear text. We should probably see, yep. So you can see here, first name showed up, last name showed up. And if we take a look at the email address, you can also see the email address is now in full clear text instead of being redacted. So giving privileges to users based on group membership is really easy. It also works at the user level, of course. I have an example in the ACLs in just a second there. But this gives you a really, really flexible way of sort of organizing your users and giving them access to data. And what we can now also do is, if we take another look at what Stackable control extracted for us, it also gave us the superset endpoint. So if we want to have a look at superset here, we'll just copy this. And if we now head into our browser here, and you can see it tells us to sign in with Keycloak, because this is hooked up to OpenID Connect as well. But if I just click on that, I don't need to enter any user information or password or anything. Because I logged in earlier, Superset now reused the single sign-on information that we just used for Trino as well. Basically, and if you click here on profile, you can see I got logged in as Sophia Clark based on the on my login, like, I don't know, when it was 15 or 20 minutes ago before we started looking at Trino. So that's quite a nifty thing to do. All right, so that's how it works, or how it looks from the outside. But how does it look under the covers? Let's take a quick look at the actual ACLs that we apply to the stack. So for that, I'll switch to our. So I've taken the ACLs that we apply to the cluster from our demo code, and again, I'll have a link for you later on. Link in the description below. And if you want to play with this, you can do it. All of this is open source and available, and I'll show you where it is in just a sec. But for now, I've just copied this out of there to make it a bit easier to read here, and I'll highlight the sections that I'll talk about as I go along. So all the ACLs that we apply, if we think back to the second slide, I think that I showed, infrastructure as code. Basically, when we say that, what we mean is as much as possible as code. It's not everything is code, but we try to get as close as we can. So as you can see, even this is in a config map in Kubernetes. So up here, you can see this is just a regular Kubernetes config map YAML header, which means you can keep it with your cluster definition in source control and then just use GitOps tools to deploy it to the cluster, and it just works. So we've got lots of customers actually integrating with this that have their own deployment systems. Ansible, many come to mind, that sort of take ACL information from whatever source of truth those users have, massages it into shape, and then pulls it in here so that it can be applied. So it's basically an API that we expose to our users to allow to programmatically write ACLs. So this is not really interesting. Let's jump down a bit to where the, oops, I lost my place. Right, there we are. So you can see this is just a little bit down. Up here is the header that we were just talking about, and this is where the actual policies start now. So in order to populate the demo, we obviously need a few technical users that are allowed to create tables, create schemas, and all of that stuff. So we have a data import user. And what this also showcases is it's not only possible to authorize based on group membership, you can also do user-based ACLs in here. And basically this just says the data import user is allowed to do everything in the Lakehouse schema, because that user creates schemas, creates tables, like ingests data. Basically, it's very easy. This is the super user for this demo environment. And then if you go a little bit further down, we can see the group compliance and regulation analytics. This is now the generic access about the slide that I heard earlier. So basically compliance and regulation analytics, they get access to their own schema. The schema compliance analytics, they are allowed to select, insert, delete, update, ownership, grant, select. Basically, this is their schema. They're allowed to do whatever they want in there. And for the customer service and analytics departments, the very same thing. Catalog, Lakehouse, schema, customer analytics, and they get the same rights in their schema. So basically anybody who is in those groups can see, view, change those schemas. That's the fairly simple use case. Going on for a bit more complicated stuff, let's have a look at the column-based access control that I demoed earlier. So as we said, the compliance and regulation team is allowed selective access to the customer table in customer analytics. So you can see here, they are only allowed the privilege to select, can't delete, can't update, can't do anything. They're only allowed to look, but they are not allowed to see the columns, see first name, see last name, see birthday, and birth month. And again, we saw that earlier. When they try to query from those, they get rejected, get an error, or they just don't show up in the output of select star statement. So that's the column-based access part. And then if we look at the next few lines, that's the hash of the customer ID. So basically you can write SQL functions here to apply hashes to whatever those people are allowed to query from here. And for the email address, we just do a regex replace and cut out pieces of the first pieces of the email address and replace that with the 3 dashes that we saw earlier in the output. So that's that's basically the redacting access to the data. And the last one we had was for the employees table. So basically, this is the schema employees, table employees. This basically applies to everybody. We don't have a group, we don't have a user, we don't have nothing. But this is filtered down, and the filter is basically also part of a SQL statement that Trino will just add to whatever the user runs as a select on their table. And that then just said you can see yourself, which is the username equals current user part, or supervisor equals current user. So if the record that's trying to be selected, the super user equals the current user, supervisor, sorry, then you can also see that. And we saw that with Sophia earlier when she ran a select on the employees table. The second bit back here, supervisor equals current user, was effective, and she was able to see the data about her reports. So basically, this allows you to filter down basically on arbitrary information what people are allowed to query from tables. That's a really, really powerful tool to restrict access to data. All right, so that covers Trino. There's a bit more in here, but I think I've pulled out the most interesting bits and pieces. But again, if you're interested to learn more, it's all available, and I'll show you when in just a sec. Please feel free to go ahead and take a look at it. And if you have any questions, do reach out to us. The second piece of ACLs that we're going to look at is the HDFS regular rules. So as I mentioned earlier, for HDFS, we've foregone impersonation. So in HDFS, we pretty much just have technical users that basically shows. Again, it's also a config map. This one is a little bit longer because for Trino, we split out the policies from the actual rules that apply the policies. But for HDFS, since this works very well, or since these are very easy, we just added them as policies at the very bottom of the config map. And if we jump down here, you can see the ACL section here is fairly simple. we have the identity, which is basically the Kerberos identity, because Trino obtains a Kerberos ticket and passes that to HDFS, which is then verified. And then the identity that gets back from that can be used in these ACLs. You can also shorten that and make that nicer. There's a couple of settings around that you can use. And as you can see, we have the Trino user and the Spark user, because those two are the ones that interface with HDFS to store data and retrieve data. The Spark job, as I mentioned earlier, we have 1 or 2 running that actually write data to the platform. And Trino, yeah, again, authentication against Trino, or Trino, when Superset connects to Trino, it does use impersonation, but all the actual authorization based on business rules and regulations are done in Trino, and Trino is just able to query everything in Hadoop. Because especially, for example, the column and row level based access control would be very hard to do in Hadoop, basically because we need to access on file level there. And since it's already implemented in Trino, it's really easy to do in Trino. So for Hadoop, we've just chosen to do a technical user here. And that pretty much brings us to the end of the demo. I'll just jump back here to the sites. 2 quick things before we finish. As I mentioned earlier, you can try all of this yourself. I'm actually in the way now, but anyway. We do have documentation for this demonstration, and we do have the actual code. So nothing that I did today is behind any kind of paywall, or you don't need to log in for anything. It's all open source in there. If you just head to the link that's in the barcode up here or written below, you'll find documentation about how to start this demo, how to play with this demo, and how to basically do what all I did and just showed to you. It's really, really simple, and you should be up and running within probably 10 minutes. Yeah, basically, as you can see here, we have a couple of components in the demo, and that's all being deployed automatically for you. And then, last but not least, a call out, come and see us. We are at a couple of events in the near future. I'll be in Bratislava for the Community Over Code conference of the Apache Software Foundation. I think Lars is going to give a talk at the Berlin Buzzwords. Highly recommend that. It summarizes all our learnings from the gazillions of operators that we built. And then at Cloudland, there will be a talk, and obviously we'll be at the World of Data from our partner, Betelligent. So if you're interested in meeting us, come find us and shake our hands or say hi at one of these events. I'd be looking forward to meeting all of you. And with that, hopefully sort of on time, I'll head over to questions and discussion.